Interstellar travel. Everything you need to know. Scientists have recently discovered the mind-blowing truth. The closest star to our solar system, Proxima Centauri, is not as distant as once thought. Breakthroughs in theoretical physics suggest space travel could be possible. But how? At what cost? In this video, I will tell you about the concepts of interstellar travel in detail and the challenges along the way. Stay tuned till the end so you don't miss any interesting points. Let's dive in. First, let's see what interstellar travel is. Interstellar travel is the hypothetical or actual journey between stars or planetary systems within a galaxy. It involves traversing vast distances, typically measured in light years, the distance that light travels in 1 year. This form of travel extends beyond interplanetary missions, which focus on moving between planets within a single solar system. Interstellar travel encompasses exploring distant stars, potentially habitable exoplanets, and the vast voids of space between celestial bodies. It requires propulsion systems capable of sustaining long-term journeys and technologies for life support and navigation over potential decades or centuries. Interstellar travel remains largely theoretical in practice due to the immense distances involved and the current limitations of propulsion technology. Still, it represents a frontier that captivates scientific and speculative imagination. Interstellar space travel faces many challenges and complexities that must be overcome before humanity can go beyond our solar system. One of the major obstacles is the vast distances involved. Even reaching the nearest star would require travel times measured in decades or centuries with current technology. Additionally, the need for propulsion systems capable of sustaining such lengthy journeys poses another significant challenge. Energy requirements for accelerating to near light speeds and decelerating upon arrival are immense and necessitate propulsion efficiency and energy generation breakthroughs. As you know, dangers posed by cosmic radiation and micrometeoroids during extended voyages across interstellar distances must be mitigated to ensure the safety of crew and spacecraft alike. Furthermore, prolonged space travel's psychological effects on human occupants present other hurdles, demanding solutions for maintaining crew health and morale over extended periods in the isolation of deep space. Overcoming these challenges will require innovative technologies, rigorous planning, and international cooperation to make interstellar space travel a feasible yet unique reality for future generations. Did you know the prime targets for interstellar travel? Prime target stars for interstellar travel are typically those that are closest to our solar system, as they present the most feasible initial destinations due to the vast distances involved. Proxima Centauri is the closest known star to the Sun, located about 4.243 light-years away in the Alpha Centauri system. It has been a focal point for potential interstellar missions due to its relative proximity. Alpha Centauri A and B are two other stars in the Alpha Centauri system, about 4.37 light-years away. Alpha Centauri A is a Sun-like star and has been considered alongside Proxima Centauri for interstellar travel due to its proximity. Located about 5.96 light-years away, Barnard's star is another close target for interstellar missions. It is a red dwarf star and the fourth closest known individual star system to the Sun. Wolf 359 is a red dwarf star located about 7.78 light-years away. It is one of the nearest stars to the Sun and has been considered as a potential target for interstellar missions. Approximately 8.29 light-years away, Lilandi 21185 is a nearby star system that has been of interest for interstellar exploration due to its relative proximity. These stars are chosen not only for their distance, but also for their spectral type, the potential habitability of any exoplanets, and the feasibility of reaching them with current or near-future propulsion technologies. Subscribe to the channel before I move towards some of the unique technologies. Press the bell icon so you won't miss any updates. What are the technologies that will enable interstellar travel? Let's see. A generation ship is a conceptual spacecraft designed for a long-duration journey between stars, where the travel time spans multiple generations of inhabitants. The fundamental idea behind a generation ship is to overcome the immense distances of interstellar space, which would otherwise require travel times far exceeding a single human lifespan using current propulsion technologies. The design of a generation ship revolves around creating a self-sustaining ecosystem capable of supporting human life for centuries or even millennia. These spacecraft would be featured for recycling air, water and nutrients, and facilities for agriculture, waste management and energy generation. Such self-contained ecosystems are crucial for maintaining the health and survival of the crew over extended periods without relying on resupply from Earth. Most importantly, the population is very critical in terms of generation ships. Initially, the ship would carry a diverse population of crew members, including engineers, scientists, medical professionals and other specialists essential for operating and maintaining the spacecraft systems. One of the significant challenges of generation ships is coping with the psychological, social and physiological impacts of long-term space travel on successive generations. Strategies to maintain social cohesion, education and the transmission of cultural heritage are essential for preventing social breakdown and ensuring a harmonious society on board. Structured social organisations, governance systems and recreational activities would play a vital role in maintaining morale and mental health. Now let's discuss warp drives. A warp drive is a theoretical idea that suggests a way to achieve faster than light travel by manipulating space-time. Unlike conventional propulsion systems that accelerate mass to near light speeds, a warp drive would create a warp bubble around a spacecraft, allowing it to ride on a wave of compressed space-time. In principle, a warp drive would compress space-time in front of the spacecraft and expand it behind, effectively contracting the space in front of the ship and expanding the space behind it. This manipulation of space-time would allow the spacecraft to surf through a warp bubble, travelling faster than light relative to the surrounding space. The benefits of a warp drive include the potential to traverse vast interstellar distances within reasonable timeframes, enabling exploration of distant star systems and potentially even other galaxies. However, the warp drive concept faces significant challenges and remains purely theoretical. One major problem is the enormous energy requirements needed to create and sustain a warp bubble of sufficient size. Ever heard about wormholes? They are hypothetical pathways through space-time that create shortcuts for long journeys in the cosmic world. The concept of a wormhole visualizes space-time as a fabric that can be bent and manipulated, creating a tunnel-like structure connecting two separate regions of space. Theoretically, a spacecraft entering one end of a wormhole could emerge at the other end almost instantaneously, bypassing the vast distances that would typically require immense amounts of time to traverse using conventional propulsion. Wormholes are characterized by their two mouths, each opening potentially in different locations and even other universes or dimensions. Well, theoretical physicists have explored various types of wormholes as well. Traversable wormholes are the theoretical concepts related to wormholes through which matter could pass, enabling interstellar travel. To remain stable and traversable, they would require exotic matter with negative energy densities to counteract the gravitational forces that would otherwise collapse the wormhole. The next are black hole wormholes. Some theories suggest that black holes can have wormholes within their event horizons. These wormholes, known as Schwarzschild wormholes, would connect the black hole's interior to a separate region of space-time. Have you ever heard about the light sails? Light sails are a fantastic concept for interstellar space travel, leveraging the pressure of photons emitted from a powerful laser, or the sun, to propel spacecraft across vast distances. Unlike conventional rockets that rely on fuel, light sails use the momentum from photons to generate acceleration. This approach capitalizes on the fact that photons have momentum, and when directed onto a large reflective sail, they can gradually accelerate the spacecraft to significant velocities over time. The potential of light sails lies in their ability to reach speeds that far exceed those achievable by chemical or nuclear propulsion systems. This could enable missions to nearby star systems within human lifetimes, revolutionizing our understanding and exploration of the cosmos. Now, every concept has its challenges and limitations. The significant challenges include designing lightweight yet durable sails to withstand the rigors of space travel and develop powerful enough laser systems to provide the necessary photon pressure over extended distances. Now, The last one is way more interesting. Antimatter propulsion is a theoretical concept in space travel that leverages the immense energy released when antimatter particles annihilate with their counterparts, ordinary matter. Antimatter, which consists of particles like antiprotons and positrons, possesses properties opposite to those of ordinary matter particles, such as protons and electrons. The fantastic part of antimatter propulsion is its energy density. When antimatter particles encounter ordinary matter, they annihilate, converting their mass energy into energy according to Einstein's famous equation, E equals mc squared. This process releases energy tens of thousands of times more potent than chemical reactions used in conventional rocket fuels. Harnessing this energy could enable spacecraft to achieve velocities approaching the speed of light, dramatically reducing travel times to distant stars and beyond. Antimatter propulsion systems would involve generating, storing, and controlling antimatter particles. This poses significant technological challenges, as antimatter is exceedingly rare in the universe and difficult to produce and store. Now, let's recall essential points from today's video. Interstellar space travel challenges us to push the boundaries of human exploration and technological innovation beyond our solar system. It involves navigating long distances measured in light years, which requires propulsion systems capable of achieving speeds that approach or exceed the speed of light. The timeframes involved in interstellar travel are immense, potentially spanning decades to centuries or more. Concepts like generation ships may be required to sustain multiple generations of travellers throughout the journey. Overcoming the technological hurdles, including life support systems, radiation shielding, and maintaining crew health over extended periods in isolated environments, presents significant challenges. The knowledge about the cosmic world and the theoretical concept of travelling in this world is immense. We should always go for more understanding of the magical world of the cosmic and what are the mysteries that lie in it. Share your comments, thoughts, or questions in the comments section.